Hey guys, Angela here and welcome back. Today we're going to be looking at grade 12 arithmetic series. It is a series that you should be familiar with. You would have done it in previous grades, but now the application thereof becomes more important. So an arithmetic series is one where there's a constant difference. So if we, for example, look at 2, 4, 6, 8, every time there's a consistent difference of 2. So it has a first difference that is the same. So you'll remember from quadratic equations from last year that a quadratic formula has a second difference that is the same, where an arithmetic sequence has a first difference that is the same. Another name for an arithmetic sequence is a linear pattern. And the formula for a linear pattern is as follows. Tn is equal to a plus n minus 1 d, where a is my first term and d is my constant difference. So there's another way of writing it, and that is because a is my first term is always just a, then my second term is a plus d, then my third term is a plus 2d, and my fourth term is a plus 3d. So this becomes important when we start using variables, so just keep this one in mind, you do still use it. And then to get the common difference, so there's a formula for the common difference, and that formula is d is equal to t n plus 1 minus tn. Right, so it is the two terms, the bigger one minus the smaller one, or rather the one that is on the right hand side minus the one on the left hand side. Alright, so in addition to this formula, this is the formula for determining, so Tn is my common term, or the formula. In addition to having a formula or a Tn, we also have a sum of. So with an arithmetic sequence, we have the most common one, so that is Sn is equal to n over 2, 2a plus n minus 1 times d. Or we can say Sn is equal to n over 2, a plus l. So a sum of is if my formula, for example, looks as follows. It is 4, 10, 16, so on and so forth. The sum of would be 4 plus 10 plus 16 plus so on and so forth. So it's basically how many, if I add all of the numbers in that specific sequence, what would my final answer be? Alright, and that's what the Sn stands for. I know it looks like a 5, but it's not, it's an S. Let me just make that nice and clear. It's an Sn. Alright, so that is the two concepts that you need to be familiar with in terms of series and sequences for an arithmetic sequence, is firstly the general formula and then the sum of. So the characteristics of an arithmetic sequence is number 1, it's linear in nature, which means it forms a pattern that can be plotted on a graph in a straight line. So if I had to plot it, it would either look like that or it would look like that. The second characteristic is there's always a constant difference. So if your series, for example, looks like this. The difference between them are not constant. So this would not be considered an arithmetic sequence. Then the third characteristic that we have is predictability. So predictability means that I'm able to predict the next number in the sequence based on the information that I already have. So for example, this one, there is no predictability because it goes 1, 2, 2, 3 in terms of differences. So it will be very difficult for me to determine what the next example would be. So let's say, for example, let's go look at a few examples on how to do this. So my first example is as follows. My first term in a sequence is 5 and my common difference is 3. We have to go calculate the 10th term in the sequence. So we're going to say Tn is equal to A plus N minus 1 times D. A is my first term, which is 5. N is my term, which is 10. And D is my difference, which is 3. 9 times 3 is 27. So the 10th term will be equal to 32. Right, so that's the first example. The second example is if they had to say to me, find the sum of the first 10 terms, where the first term is 3 and the difference is 5. Right, so now this is a bit of a different question because now there's an important word here, and that is a sum of. So when it's sum of, I'm no longer working with Tn. So if we go back to our two formulae that we discussed up here, the first one, this one, was the sum of numbers in a sequence is equal to n, so the number of numbers in the sequence, over 2 times by 2 times the first term plus n minus 1 times d. So you're familiar with all of those. N is the number of terms I have, A is my first term, and D is my constant difference. The other formula I can use is the formula that says the sum of is my n over 2, so the number of terms that I have, multiplied by my first term, and this stands for my last term. So that's what that stands for. Right, so if we have a look over here, problem here is we don't have the last term, so we cannot use the the second formula. We would have to use the first one. So let's quickly go write it down. So my final answer for the sum of my first 10 terms added together is 255. So you'll see that the formula is very, very similar to the Tn formula. The only difference is we're going to be multiplying the first term by 2, and we have to put the n over 2 in front of the bracket. Right, so there's an example of that one. Then let's have a look at a third example. So a third example would be, they give us the sequence. Let's change colors. They give us the sequence as follows. And they ask us to find the common difference. So remember that formula that I showed you, D is equal to Tn plus 1 minus Tn. So we can basically go and take any term, it doesn't really matter. I'm going to say 13 minus 7, and therefore my difference is going to be 6. All right, where can we use arithmetic sequences? So very often in saving, so this would be your simple interest formula. We also use it in patterns, so understanding regular intervals such as bus schedules or construction timelines, and also to analyze the uniform growth in fields like economics. All right, guys, I hope that helped. Until next